Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 14 of the January daily LeetCode challenge. So first of all, big congratulations to all of you who have made it till here, because today we are going to complete first 2 weeks in this 2025 and also in this particular January daily LeetCode challenge. Okay, so if you haven't considered till this point, a big congratulations to all of you to begin with. And now coming to today's question, it's going to be a very interesting question. Okay, this is the kind of question where see, you can also solve it. Using the brute force way, and at the same time you can optimize it. Okay, there are so many possibilities here for optimization. Okay, so this is one such question which I will say that you should be very much I will say that if this kind of question comes in interview, you should be feeling that you are fortunate. Okay, because here there is lot of thing for you to explain to the interviewer. At the same time, there are so many optimizations possible. Okay, so even if they give us some follow-up question or they ask you to optimize, there's always some possibility left for you to do that. Okay, so in today's question I will be showing both Python and Java solution, and I will show you like total of 3 solutions in total. Okay, so let us begin with this question. It is 2657. Find the prefix common array to two arrays. Okay, find the prefix common array of two arrays. So do not worry about what these things are, like prefix common array and what it means. Do not worry about that. It's just the name. It has nothing much to do with the prefix. Okay, so some people will read the word prefix and they will be starting recollecting. Okay, what are the ones I know for prefix and all that. Okay, these are not needed here because this question is not exactly what the title of the question says. Okay, we'll see that. So coming to the questions here, there are two arrays given to us. Okay, let me zoom in and let us begin now. So as you can see, there are two arrays given to us. Okay, the array and the array B. Okay, so the length of all of them are going to be same. Okay, length of array and array B are always going to be same, and the maximum length that they can go is up to 50. Now you will be asking me, okay, if the length is 50, then why it is marked as a medium question? We'll come to that. But again, yeah, you can say this is slightly on the easier side. Okay, so the two arrays are going to have the same length. They are integer arrays, and at max they are going to have a length of 50. Okay, then all the elements in a of I and b of I are going to be in the range of 1 to n. Okay, n is the length, and similarly the highest value is also going to be n in that. Okay, the last one. Okay, the last one, what it means is, for understanding this part, you have to know what is a permutation of an integers. Okay, what is that? We'll see in the question. Okay, they have explained this particular thing in the question, and while designing the optimal solution, we will be using this part. Okay, we will be using this particular statement in our optimal solution. Okay, so as of now we do not need it, but yeah, in the optimal solution that I will show you, that is the solution number 3, we will be using this part. Okay, this is going to play a very important role while deciding the, or you can say like while achieving the optimal solution. Okay, we'll come to this at a later point of this video. Now coming to the question, see here, you are given two zero index integer permutations a and b of length n. Okay, so they are saying that a and b are two permutations. What is a permutation? We'll come to that now. They have not explained that till now. Just for now, you have to assume that there is something called permutation, and a and b are two integer permutations. Okay, which are starting from zero indexed. They are like zero indexed integer permutations, right? A prefix common array. Now they are coming to a new term. Okay, this is going to a new term. We have seen this term also. This is again a new term for us. What are these things? We'll come to that. Okay, slowly we'll get to know that. But for now, this is a new term, and this is also going to be a new term. Okay, a prefix common array of a and b is an array C such that C of I is equal to count of numbers that are present at or before the index I in both a and b. Okay, I will again repeat. Okay, we'll come to the statement in a minute, but for now let us begin. But let's complete the question. Return the prefix common array of a and b. Okay, they are saying we have to return a prefix common array of a and b, and they are saying, like, if C is the prefix common array of a and b, then C of I is equal to the count of numbers that are present at or before the index I in both a and b. Okay, now they're explaining this part. Now see the part, as I mentioned, like this particular part, permutation of an integer. What it means is they have explained it here. A sequence of an integers is called permutation if it contains all the integers from 1 to n only once. Okay, so what they are trying to tell is that a and b are going to have exactly 1 to n integers. Okay, none of them are going to repeat, all of them are going to unique numbers, and the ranges are also fixed there, 1 to n. Okay, for example, if you see the length of this is 4, that means it is going to have numbers between 1 to 4. None of them will be repeating. Okay, simple as that. And all the numbers in this range are going to be present. Okay, similar this part here, the length is 4, so the numbers are going to be 1 to 4. Okay, as simple as that. If you see another example also here, also if you see the length is 3, so they are going to have 1 to 3 numbers. Okay, as simple as 1 to 3, as simple as that. So that is what they are trying to say you this. We'll come to this when we are discussing the solution number 3, that is the optimal solution. For now we need to focus on this particular statement, because the answer that we have to return, okay, the answer that we have to return, okay, is coming from this particular statement. Okay, they are saying that for each index, that is C, we have to return array as the answer. So for each, how to calculate each index in this array, that's what they're trying to tell you. C of I is going to be the ith index in our answer. Okay, just ith value in our answer. C of I is equal to the count of numbers that are present at or before the index I in both a and b. So let us see the example one. See here, for example, see here, if I go to the zeroth index, okay, here 1 is present, here 3 is present. So as of now, there is nothing common we have seen till now. Okay, so we will say that the zeroth index of the answer is also 0, because there is nothing common till this point in A and B. Okay, now let us see this index number 1. Okay, when we come to index number 1, see this whole part. If we go to index number 1, we have to take everything that came left of it. Okay, so when we are at index number 1, so we have 1 and 3 in A, A, and we have 3 and 1 in B. Now if you see, they are matching, that is 1 and 3 are common in A, and 1 and 3 are also present in B. Okay, the order doesn't matter. Remember, the order doesn't matter. You see, the question they are saying is equal to the count of numbers that are present at or before the index I in both A and B. Okay, this particular statement is very important. This number should be present in both A and B. So in this case, when I put index 1, I've already seen 1 and 3 in A, and I've already seen 1 and 3 in B also. So when we are at index 1, we get to know that there are two numbers which are common in A and B when we are at index 2. Okay, so we have to return 2 here. Okay, now coming to the index number. Okay, we are coming to this index. Okay, index number 2 now. So when we're index number 2, see this part. So when we're index number 2, we have to take current index, that is index number 2, and all the elements which are left of index number 2. Okay, so it is 1, 3, and 2, and here again it is 1, 3, and 2. Okay, I am not following the same order. Okay, but still the numbers are same, right? 1, 3, and 2 are present here also. So the idea here is, when we are at index number 2, 3 elements are going to be common. So we have to write 3 here. Okay, similarly, when we are at index number 4, I have 1, 2, 3, 4, and here also I'm going to have 1, 2, 3, 4. So it is always going to be 4. Okay, as simple as that, right? Yep. Okay, one more thing. Okay, let me give you a hint so that it becomes very easy for you to understand this part. Can you quickly tell me this last number? Okay, this is going to be a hint for you. So if you have been following the video till now, okay, this you will find like a bonus point. See this part. Can you quickly tell me, can you predict this particular part of the answer without doing any calculation? It's going to be yes. See here, the numbers are always going to be 1 to n. Okay, so here also it is going to be 1 to n. So by the time we reach the last index, we would have seen every number. So the last number in the answer is going to be always n. Okay, n is, which is the length of the A and B. Okay, so here also we see the length is 3. So the last value in the answer is going to be 3. Okay, so this is just a bonus point for you. This will help you understand the problem even better. Okay, so I will again repeat what we have done till now. Let's go to example. See here, I am at index number 0. I have seen 2 here, I have seen 3 here. So as of now, nothing is common between A and B. So the answer here is 0. Okay, index 0 for the answer is 0. Similarly, when I am at index number 1, I have 2 and 3, and when I have index number 1 of B, I have 3 and 1. Okay, so at this point, there is only one element which is common. If you see, 3 is present here also, and 3 is present here also. There's only one element which is common. So I will add 1 here. Okay, similarly, when I reach the last index, obviously all the elements will now be common. Okay, so we have to write 3 here. Okay, so I again repeat what we are doing. When I am at index I, okay, so you will have to time how many elements. Okay, that is count of numbers that are present at or before the index I in both A and B. Okay, so how many elements are present in both A and B. Okay, that is something that you have to return. Again, this point will come, we will come to this point at last. Okay, let me show the some of you can say kind of a brute force. It's not a truly brute force, but yeah, there is some operation involved. But I want to teach you the concept of set also in this question, so I am choosing this. Okay, as simple as that. So see this part now. In this solution, what I'm doing is, see here I'm going to use some set operations, because in my last video when I showed you the XOR operator to toggle the numbers, a lot of you felt that okay, this was something that they were not knowing. Okay, so for that reason I have included this part in this video. This is called the set intersection. We'll come to this what it means, but yeah, you will get to learn this, and again we'll see the optimal solution also. Okay, so what I'm doing is, first, let me keep the example on side by side. Yeah, I am creating answer which will be written at last. Okay, fine. Then I am taking the length of it. Both length for A and B are going to be same. I'm creating two sets. Okay, first is called the set A, second is called the set B. Set A is going to store all the elements of set A, and similarly set B is going to store all the elements of set B. Okay, now I'm going from 0 to n minus 1. Okay, at each index, for the eighth element, that is the element from A, that is A of I, I'm going to add in set of A. Similarly, B of I, I'm going to add in set B. Okay, now I will take the intersection for the sets. Okay, what is the intersection? See this part. I'm opening the official documentation of Python. See this part. This tells it as intersection T. Okay, what it means, we can write it like this also, S and T. This is the AND operator. Okay, single operator, ampersand AND operator, S and T. What it means is new sets with elements common to S and T. This will give me the common elements in S and T. Okay, this is the official documentation. You can go through this. I can give this link in the comment section. But what it will do is, it will take the elements which are common to S and T. Okay, So that is what I'm doing. So that is what we require in this question, right? We require that the at, let us say, any index I towards its left, okay, that's if you see the exact what they are mentioning is, okay, at or before index I, how many elements are common in both a and b. Okay, at or before index I, how many elements are common in both a and b. That is, you have to something that you have written. Okay, for that reason I'm taking a set intersection. This will tell me how many elements are common in a and b. Okay, and I'm taking the length of that. Okay, because remember, the set intersection will again give a set. I need the length of the set, so I'm taking the length of it, and that I'm going to append to my answer. Okay, and finally I'm returning the answer. So what we are doing, see here how it will work. First, I will add 1 to set A. Okay, similarly I will add 3 to set B. Okay, similarly I will add 3 to set A, I will add 1 to set B, and so on. Okay, at each step what I will doing, I will be taking the intersection. Okay, when I have 1 and 3 here, and I have 3 and 1 here, again the set intersection will give both of them because both are common, right? So we will be getting the length here of the common elements we have seen at that particular point or at that particular index. So for each I, that is for 0 to n minus 1, for each value in that, we will be appending the common elements we have seen till now. Okay, so that will be appending in the answer, and finally we're writing the answer. Okay, so I'm again showing you the documentation here. See, S and T, this basically means the intersection. See, set is a particular concept, right? You might have learned this, I guess, in your 12th standard also. That is, if you are in a CBSE background, you would have learned these things in your like 12th standard also, right? These are mathematical topics. Set, okay, what is set? You will get to know that when you, it's there in 12th standard mathematics. Okay, so set intersection will tell you how many common elements are there in both of them. Okay, as simple as that, right? So yep, that was the solution. If you talk about the space and time complexity, as you can see, at last time, storing all the elements. So set A will have n elements, set B is also going to have n elements. So the time complexity is going to be O of n. Okay, remember, for the answer I am not going to calculate this in the space complexity. Even if I calculate, it won't change, but still the variable that you're returning, this should not be counted in the space complexity, because that is the requirement of the question. That's why you're doing it. Okay, it is not part of your algorithm, right? As simple as that. Now if you come to time complexity, see here the trick comes. See, I'm using a for loop. Inside the for loop I am using this particular operation. Okay, so the time complexity will now depend on what is the how much time it is this particular operation is going to take. For that reason I'm using this particular documentation. See here, they are talking about intersection here. They are saying that the intersection is basically going to take this much time. That is minimum length of s1 comma length of s2. Okay, if you're doing intersection between sn and s2, this intersection operation is going to take minimum of length of s1 comma s2. In our case, we can assume that the worst case length of a, that is, yeah, length of set a and set b is going to be n. Okay, in the worst case. So this whole operation is also going to take O of n time. Okay, in the worst case. Remember, in the worst case, whenever you're using a big O notation, you should always be considering the worst case only. So we are having n iterations, and each of the iterations, this particular operation in the worst case is going to take O of n time. So O of n into O of n, which is going to O of n square. Okay, this was the O of n square solution. Okay, I have already submitted this solution, and this also will works. It may look like a brute force, but still it works. Okay, it's this around took, I guess, 9 to 10 milliseconds. This was also a very good solution. Okay, let me tell you that. Now, one optimization that you can think of here is, I will show you one optimization here, and then we'll go to the optimal solution. Okay, so see here, you see the case here 2 is present, here also 2 is present. So the idea here is, see, whatever is the answer till this point, that is whatever is the answer for index number 1. Okay, index number 1 is this one, right? What is the answer in index number 1? Let us say if index number 2 elements match in a and b, so you can just add 1 to the answer in index number 1. Okay, that is, see this part. Let me go to the other solution. Yeah, see here, see this part. Yeah, what I'm saying is, for each element, add the a of I to the set A, add b of I to the set B. Now if a of I is equal to b of I, and you are at I which is greater than 0. Okay, what you have to do is take the previous answer. Okay, take answer of -1 and add 1 to it. What is answer of -1? Answer of -1 means the last added answer. Okay, this is the last added answer. You have to take that and you have to add 1. Okay, why it is working? See here, let us say this part, here also 2 is there, here also 2 is there. So whatever with the number of elements previously for this index, okay, that is for index number 1, whatever was the answer, that is, this was the answer, right? You have to just add 1 to it and you have to get 3. Okay, that is what is the logic. So whatever was the answer here, you have to just add 1 to it and you have to get 3. Okay, how this works, because this is, and this are common. Okay, so whatever with the previous elements, we are just going to add 1 to it. Okay, so these two elements were there, here these two elements were there. So whatever is the number of common elements in these two, that is, here it is the cases 2, you have to just add 1 to it and you have to get 3. Okay, so this condition will work now. If a of I is equal to b of I and I is greater than 0, just take the last element added and add 1 to it. Okay, and that is going to be the answer for the current element. Okay, so if you see what is the advantage here, instead of taking the set difference again and again, if the elements are equal at the ith index in a and b, we can just append the answer directly. Okay, if this is not the case, only then we are going to take the set difference. Okay, so this was the solution. This is again like a bit of optimization, but yeah, more or less the time complexity and space, everything remains the same. Okay, now coming to the most optimal approach, I will be giving a hint now and then we'll go to the approach. Now see this part, now we will come to this. Okay, So can you quickly tell me what it means? This they are trying to tell you is that now each element in A and B are going to be between 1 to n. Okay, that is, each element in A and B are going to be between 1 to n. Okay, none of them are going to repeat. Till now we have not made use of this fact. Okay, if you see, just pay attention to the elements here. If you see, none of them are repeating. Okay, they're fully continuous. Okay, they're like 1 2 3 4. Okay, as simple as that. Similarly here also, if you see the elements 1 2 3 and 4. Okay, similarly if you see the constant also, they're mentioning this. It is guaranteed that A and B are both a permutation of n integers. Okay, so what is a permutation of n integers? They are saying that it contains all the integers from 1 to n exactly once. So till now we have not made use of this fact. Okay, now can you quickly tell me one thing? See here, let us say I have witnessed one now. Okay, now can you quickly tell me when is the next chance I am going to witness one again? That will happen only in B. Do you agree with me? See, one came in A, one cannot come in A again. Do you agree with me? One has to come only in B now. Do you agree with me? Right, so whenever we are seeing element for the second time, we are sure that now this is going to add to our answer. Can you, like, do you agree with me in this? See, I will again repeat. I have seen one okay, in A. Do not worry about what is A, what is B. Just see it in that way. Let us say this and this are now combined, kind of. Okay, just combined. So I have seen one now. Okay, in the zeroth index I have seen one, I have seen three. So and now I'm at three. Now three is coming for the second time. I've already seen a three. Okay, so now three is coming to me for the second time. Okay, now obviously three cannot be present in A again. Okay, so it must have been present in B only. Are you getting me what I'm saying? The idea here is, whenever I'm seeing a particular number for the second time, I'm sure that this is now a repeating value. Okay, as simple as that. That is now going to be a common value. Okay, as simple as that. So if you see the now solution that I'm designing, this is going to be the most optimal solution. See this part. See, what we are doing is, as usual, I'm creating answer. Now I'm creating a variable called common element count. Okay, initially it is 0. I'm taking the length. Now I'm going to use a single set. Previously, if you see, we were using two sets. Okay, we were using two sets previously. Now I'm going to use a single set. So what I'm doing, see this part, I'm going to each of the elements again, 0 to n minus 1. Now if a of I is in set, that is, this is the second time I am seeing this particular element, what you have to do, you have to add common element count, you have to increment. Okay, as simple as that. Let us say this is not the case, that I have not seen a of I previously, then you have to simply add it to the set. Okay, same is the case of B. If you are seeing an element for the second time, this condition will be true, and we have to increment this particular variable. If we are not seeing for the, if you are, let us say you are seeing it for the first time, then you have to simply add it to the set. Okay, so whatever is the value here, that we are going to append in the answer. So how it will work, let me see you that. Okay, yep, let me maintain a set here and then we will try to understand. Okay, let us say this is my set. Okay, okay, it will look something like this. Okay, okay, and now let us say I am at I is equal to 0. Okay, I is equal to 0 now. Okay, and also let me maintain this particular stuff also, so that you are very clear. Okay, I'm maintaining this also. Initially it will be 0. Okay, and okay, in that case let me maintain the answer also is equal to this. Okay, now I am at I equal to 0. So which are the two elements I will be facing? This. First, I'm getting one. Is one already present in my set? No, one is not present in my set. So add one to it. Okay, as simple as that. Add one to it. Similarly, I am having three here. So is three already present in my set? No, three is not present. So simply add three here. Okay, and leave. Okay, as simple as that. Okay, till now this is again 0. So at the end of the index, when we are done with index 1 for both the A and B, we are going to add whatever is the value here. We are going to add that to the answer. Okay, so answer is now 0. Okay, as simple as that. What is the next value? Now I'm at I equal to 1. Okay, now I'm at equal to 1. So here it is 3 is there. Okay, I'm going to check, is 3 present in my set? Yes, it is present. So what you have to do, you have to increment this by 1 now. Okay, this is coming for the second time, that means this is now going to act as a common prefix. So you have to increment this by 1. Okay, as simple as that. Now I'm at index 1 of B. Okay, previously I saw index 1 of A, now I'm at index 1 of B. Is 1 already present? Yes, 1 is also already present. So again you will have to increment this by 1. Okay, make it 2. Now I am done with both A and B index 1. So whatever is the value here, just append it to the answer. So now 2 will come to the answer. Okay, as simple as that. Now I will increment I also. Now I will be at index 2. Okay, now I'm at index 2. 2 is present. Is 2 there in my set? No, 2 is not there in my set. So what I have to do, simply add 2 here. Okay, similarly now I'm going to process index 2 of B. Is 2 there in the set? Yes, 2 was there in the set. Okay, is 2 is there in the set. So what I have to do, add this one. Okay, add 1 to this. Okay, fine. Now I am done with index number 2 for both A and B. So whatever is the value here, just append that to the answer. So I have answer 3, right? And as I mentioned, the last value is always n, is going to be n only always. Still, like, as formality, let me do it. So here 4 is present, 4 is not there in the set. What I have to do, I will have to add 4 to the set now. Okay, so I added 4. Now B, if, okay, the last element is 4. Okay, is 4 there in the set? Yes, it has to be there now. Okay, remember, because it is a permutation. Okay, yep, it has to be then. Okay, 4 has to be there. So again, you are going to add 1 to the answer here, that is this particular variable, and finally you will have to add the variable here. Okay, what is the value here, that has to be added here. Okay, so this is going to be our final answer. Okay, so yep, that is how we are getting this particular answer. So this is how it works. So what happens is we are now using this particular logic. Okay, this tells that each element is going to be present only once in A and B. Okay, so let us say we have seen 1. Okay, and the second time we are seeing it, so it must be present in B only, that is we are going to see in B only. Okay, 1 is not going to repeat in A. Okay, so it is going to be in B only, and since it is the second time we are seeing it, so the first time must have been in. Let me repeat it again. Let us say I am seeing 1 in B for this second time. Okay, so that means the previous one would have been in A. So that means I am, this particular one is going to add as a prefix now. Okay, as a common prefix. So that is why we are always incrementing this by 1. Okay, as simple as that. So yep, that was the logic, friends, for this. And if you talk about space and time complexity of this solution, okay, since we are not doing any set difference here, okay, we are just using a okay, if you talk about space complexity, we are just using a set, and this set is going to store n elements in the worst case. Okay, so it is O of n. Now if you talk about the time complexity, as you can see, we are using a single for loop, and inside the for loop also we are not doing anything which is going to take more than O of 1 time. Okay, so it is going to strictly O of n. So this was the optimal solution in Python. Okay, here we have removed the set, okay, the set algorithm that we're doing, right? You can call it like this set intersection, that we are not using it. Okay, as simple as that. We are making use of this particular fact. Okay, this fact is helping us get the optimal solution. Okay, this was the Python solution for that. Okay, now coming to the Java of the same. So this is the Java solution for that. If you see what is happening here, same thing. I am doing first of all capturing the length of a. If you see the return type is, see, normally in Java they will give you a list of integers as the return type, but here they are giving a array of integer. Okay, so that is something that you have to take care. Okay, then this element as it is that we had in Python, we are defining it here. I'm declaring the answer. It is going to have length n. I'm going to declare a set now. Okay, since I know that at max it has to show n elements, so I'm passing n here directly. Okay, in order to see, if you don't pass any value here, it will default value will be allotted. So what can happen here is, no, let us say it had already n values now, and it is going to exceed some value. Okay, so what will happen is, in during runtime it will be asking for a new value from the heap. To avoid that, what we will do is we have to write a value here that will ensure that during before run starts, that time itself the real, okay, the value to accommodate n variables is already allocated. Okay, that is something that you can use to optimize the code. Okay, as simple as that. Next, this is same as that. I'm going from 0 to n minus 1, and whenever the a of I, if it is already contained, I am going to add this. Otherwise, I am going to simply add a of I to the set. Okay. Similarly, for b of I, if b of I is already there, simply increment this particular variable by 1, and otherwise you have to simply add b of I to the set. Okay. So whatever is the value in this variable currently, that is going to be the a of I. Okay. As simple as that for each I from 0 to n minus 1. Okay. And finally, we return the answer. So let me quickly run this and show it. Yeah, as you can see, this again clearing the test cases. I've already submitted this solution. So often that was all for this particular video. This was the OFN solution for both space and time complexity. Since we are not doing any such extensive set operation, which is going to take non-constant time. Okay, all the set operations involved are going to take constant time. If you see, we are just doing and contents operation. All of these are going to take a constant time only. Okay, so for that reason, the overall complexity is going to be OFN only because of this for loop. So often that was all for this particular video. If you like my efforts, if you get to know something new, okay, because I tried my best to explain you this particular concept of set intersection. Okay, this is the link for that. You can go to the other options for the set, but know these things, like this will be very helpful to you. Okay, just with this set, if you know, you can directly solve this question in one go. Okay, so this is how I solved it initially. I know the time complexity is a bit high, but still, okay, this is a good solution to start with. Okay, as simple as that. Then you can slowly optimize like I did. Okay, so often that was all for this particular video. If you like my efforts, please do subscribe to the channel. This really gives us a lot of motivation to continue further. This is the around 90 days I've already uploaded the video, and this is the 84th day. Okay, continuously, this is the consecutive 84th day I'm uploading the video, and prior to that also I've uploaded video, but yeah, there were gaps, but now I'm doing it consistently. So if you like my efforts, or if you get something to learn at least, please do subscribe to the channel. This takes lots of effort to make this video in a regular basis. Remember that consistency, to maintain consistency, it really takes a lot of effort. So if you like this effort, or if you want to appreciate this effort, or if you have something to ask me, please do comment and please do subscribe. This really gives a lot of motivation and a reason to continue further. See you tomorrow. Thanks a lot.